Hello, welcome back. Today we are going to be learning about the structural theory of isomers. So, what is an isomer? Well, an isomer, or a constitutional isomer, is a molecule that can take many forms with the same formula. Take C2H6O, for example. C2H6O can take on two different forms. In other words, it has two isomers. The first one is this one, which has the oxygen inserted in between the two carbon atoms. And its second form, or isomer, is this one, which is ethanol, because it has this hydroxide group right there. So as you can see, isomers are the different forms that a molecule can take on with the same formula. Now we're going to see how to determine all the possible isomers of one molecule. And first we need to know this term. This is called valency. And that describes how many bonds a molecule can have. For example, tetravalent is like carbon, because carbon can have 4 bonds. Trivalent is like nitrogen because it can have 3 bonds. Divalent or bivalent is like oxygen because it can have only 2 bonds. And lastly, monovalent is like all the halogens like chlorine and fluorine because they can only take on 1 bond. Now, let's apply this to a real problem. So here's our problem on the board. We are going to determine all the structural isomers of C3H7Cl. So how we're going to start is we know a carbon chain has just a series of carbons, so let's draw that out. Now where could the chlorine possibly be located? Well, it doesn't really matter. We only know that it can't go in between 2 carbons because it can only form 1 bond. So it'll either be on one of the edge carbons or the middle carbon. For this one, let's put it on the edge. And then we can fill in the rest of the empty spaces with hydrogens, which makes exactly 7. Great, now let's draw the second form. We know that in that case, the chlorine goes on the middle carbon. And now we can fill in the empty spaces with the 7 hydrogens. And those are the 2 structural isomers, constitutional isomers, of the molecule C3H7Cl.